So in this lesson we're going to look at simultaneous equations. We're going to look at how we solve simultaneous equations through what's known as elimination. There's several ways of actually dealing with simultaneous equations. In this occasion we're going to look at solving them through elimination, which means cancelling terms out. I'll start off just by explaining what a pair of simultaneous equations are. Simultaneous equations are where you have two or more equations where the values of x and y are the same within each one. So we can use that information to go about solving them. Now, when we talk about using elimination and the fact that both the x's and the y's have the same value that we have to work out, what we can do is we can add or subtract the two equations, keeping x's of x's, y's of y's, and so on, to cancel one of the terms out, such as either the x or the y, and get the other one on its own, and then solve it that way, where we have an equation that has either only x or only y within it. And then what we can do once we have either x or y, we can substitute that value back into one of the original equations to find the other value. Okay? Now, it'll probably become more clear what I'm talking about when we get stuck into the examples here. If I look at this pair of equations, I have 2x plus 3y equals 17, which is the first equation, and the second one is x plus 3y equals 13. Now, this is probably one of our most basic examples because we have the y values have the same coefficient of 3. And what we can actually do is we can subtract the two equations from each other to eliminate the y's. Now, I'll just explain when the signs are the same like this. Everything is positive in this equation. When the signs are the same for the terms that we're trying to get rid of, we subtract to cancel them out. Okay? And we'll just make a wee note of that. When signs are the same, we subtract. And the reason I'm doing that is because as we encounter equations that have pluses and minuses, we will have to do something different. When the signs are different for the terms that we're trying to cancel it, we would actually add the two equations. But in this case, we're going to subtract the two equations. Now, just to explain what that means, okay? So basic rules of algebra, x's with x's, y's with y's, and so on. If I'm subtracting these two equations, 2x take away x leaves me with just x. 3y take away 3y is 0, so it's gone, they cancel, and that's what I was talking about. 17 take away 13 is 4. So again, as I said, probably the most basic example of a simultaneous equations question. I already have my value for x. Now that I have my value for x, I can substitute x equal to 4 into one of the original equations. It doesn't matter which one. Substitute x equal to 4 into, I'm going to pick the first one just to show you. 2x plus 3y equals 17. Okay, so if x is now 4, that means 2x, 2 times 4, I'm going to multiply using brackets, equals 17. 2 times 4 is 8, plus 3y equals 17. Now it's a very basic two-step equation, so I want to get y on its own, so I subtract 8 to get rid of it, but I have to subtract 8 from each side. 8 take away 8 is 0, so it's gone. That leaves me with 3y equals 17 take away 8, which is 9, and a 3y equals 9. I divide by 3 on each side, because I don't want 3y, I want 1y, and that leaves me with 3. So I have x equals 4, y equals 3. Now, what is always good practice, and I'll just show you for this question, but you should do it for every question, is to substitute your values for x and y into the other equation just to prove that we're correct, okay? So if I consider the second equation, x plus 3y equals 13, I can substitute my values for x and y into this, and I should get 13. So when x was 4 plus 3 times y, which is 3, should equal 13. 4 plus 3 times 3, which is 9, equals 13. Well, 4 plus 9 does indeed equal 13, so that is correct. Okay, so that's my first example. Find your value of x or y, doesn't matter what one you work out first. In this case, it was easier to find the x first because the coefficients of the y's were the same, so I just subtracted the two equations. So find my value of x, substitute it into one of the equations to find my value of y, and then check your answer by substituting your values of x and y back into the other equation. Okay. Moving on, our next example. So something similar here, only this time the signs are different, okay? Now again, I could get rid of the x's, but that would involve me manipulating both equations. So I have a value of 10x in each case. Because the coefficient of the y's here is 3 in both of these, it's easier to get rid of the y's. But the signs are different. So when the signs are different, we add the two equations, okay? When signs are different, add. Just make a wee note of that for our examples. That's for the term that you're trying to get rid of. If I was to try to get rid of the x's, they're both positive, so I'd actually end up subtracting. It's the y's we're going to get rid of here. So I'm adding the two equations. So 5x plus 2x is 7x, plus 3y plus minus 3y. And even if you weren't sure about that there, you can put that in your calculator. So I have plus 3 plus minus 3 is 0. And again, that just proves you that they will in fact cancel. Equals 26 plus 2, which is 28. Okay, 7x equals 28. Divide by 7 on both sides. And therefore x equals 4. Take my value of x equals 4, substitute it back into one of the other equations. I'll use the top equation here. Okay, so that becomes 5 times 4 plus 3y equals 26. 5 times 4 is 20 plus 3y equals 26. Two-step equation now. Subtract the 20 to get rid of it. Subtract it from the right hand side as well. So that cancels out. So I'm left with 3y equals 6. Divide by 3. Because I don't want 3y, I want 1y. So 6 divided by 3 is 2. So I get y equals 2. Okay. Now again, I would substitute in, and I'll do this one more time. Just to show you. So I'm gonna 2x minus 3y equals 2. That was my second equation. X equals 4, y equals 2. So I get 2 times 4 minus 3 times 2 should equal 2. 2 times 4 is 8. 3 times 2 is 6, and that does in fact give me 2. So that is just me checking my answer, and I can tell that it is correct. Moving on, okay, so our next example, a wee bit trickier now. I have a 2x and a 3x, and a plus 4 and a minus 4. I could multiply this equation by 3 and this equation by 2, so I have 6 x's in each. But what I'm actually going to do, so I don't have to manipulate both, is I'm going to multiply the bottom equation by 4. And the reason being that I want a y with a coefficient of 4, okay? So when you do that, multiply the whole equation by 4. So 3 times 4, 3x becomes 12x, minus y times 4 is 4y, keeping the same. 4 times 4 is 16. Now I'll bring my top equation across. I have 2x plus 4y equals 26. Okay, now I now have this in a format where I can cancel out the y's. And the signs are different. So if you remember from earlier, when the signs are different, we add the equations. So 2x plus 12x is 14x. These cancel. 26 plus 16 is 42. Okay. And I just divide. So 14 into both sides. 42 divided by 14 gives me 3. Okay, so my answer for x is 3. Substitute back in. 2x plus 4y, I've chosen the top equation this time. And this is to help me find my y value. Now I know my x. So 2 times 3 plus 4 times y equals 26. 2 times 3 is 6 plus 4y equals 26. Two-step equation at this point. Take away the 6 from each side. So I'm left with 4y equals 20. Divide by 4 on each side. Y equals 5. Okay, so I've got x is 3, y is 5. Just again, good practice. X is 3, y equals 5. I'm going to use the second equation this time. 3x minus y equals 4. So it becomes 3 times 3, take away y, which is 5, should give me 4. 3 3s are 9, take away 5 does in fact give me 4. So again, substitution, just to check my answer. Last example. This is just a type of question where what we're going to have to do is change both equations. There's nothing we can do there. Both the x terms are different, both the y terms are different, and neither share a common multiple. Sorry, this is not a common multiple of 2, nor is this a common multiple of 2, so we're going to have to change both equations. Now, again, I'm going to opt to eliminate the y's by making both these terms. I have to look for a common multiple of 2 and 3. In this case, it's going to be 6. I could do the same with that. It would just change the order in which I multiply. So if I want to change this into a 6y, I multiply this by 3. If I want to change this into a 6y, I multiply it by 2. So we'll start with the top equation multiplied by 3. So that becomes 9x plus 6y equals 48. Okay. The bottom equation is multiplied by 2, so I get 4x minus 6y equals 4. Okay? The signs are different for what I'm trying to get rid of, so I add. Okay? So 9x plus 4x is 13x. They cancel. 48 plus 4 is 52. And now we simply divide by 13 to get rid of that 13x. Okay. And we do 52 divided by 13, which gives me 4. So x is 4. The last thing we do, sorry, not the last thing before checking our answer, what we do to find our y now is we substitute x equal to 4 into one of the equations. So 3x plus 2y equals 16 is what I'm going to use. So 3 times 4 plus 2y equals 16. 3 4s are 12 plus 2y equals 16. Two-step equation at this point. Take away 12 from each side. So I get 2y equals 4, y equals 2. Because I divide by 2 each side. Again, I'm just showing the full working out for you. Alright. Substitute x equal to 4 and y equal to 2 into my other equation just to check. 2x minus 3y equals 2. So 2 times 4, take away 3 times 2 should equal 2. 2 times 4 is 8. 3 times 2 is 6. 8 take away 6 does in fact equal 2. So I know I've done it correctly. These type of questions are fairly repetitive, and best way to get any practice with them is just to try some of the past paper questions. I'm going to upload some, give them a go, and anything you're unsure about, just ask. And in later videos I will show you how to solve simultaneous equations through things such as using graphs or using substitution as a method also.